All right, thanks everybody for sticking around till the bitter end. It is indeed an exciting time, and I tried to summarize, at least in terms of volcano deformation, one of the key primary motivators for my talk today, which is that we are living in the revolution in terms of being able to monitor global volcano deformation. And so this is just showing a plot of the number of volcanoes that we know to be deforming, and you can see over the last 20 years with the advent of INSAR, we've basically quintupled the number of volcanoes that have deformed, and this number is only going to increase going forward as we increase the amount of data that we have available. So the question is, in order to use that information to try to make something useful about hazard assessments, whether these volcanoes will erupt or not, we have sort of two approaches that we'll talk about today in terms of projects that are ongoing. And one is looking backwards, trying to synthesize all these observations that we have already in terms of trying to understand under what circumstances volcano deformation might indicate an imminent hazard, and then looking forward to what we're going to be able to do with NISAR and the constellation of many different international missions that could be used to help assess this. All right, so just as a brief review, volcanoes can deform in a variety of different ways, and INSAR has been instrumental in trying to differentiate amongst the different types. Sort of the first cartoon we can start with is just a simple model of a magma chamber filling or emptying, and it sort of produces a very distinctive pattern. A dike intrusion within a volcano also produces a very distinctive pattern, as do products that are erupted onto the surface, some sort of volcanic lava, an ash, or a lahar deposit might cause some sort of subsidence and settling as a function of time. And the really great part of INSAR has been the spatial imaging aspect to be able to reveal and understand the complex deformation that happens in many volcanic areas where several things are happening simultaneously. I show a dike intrusion at the top that shows an earthquake, a dike, and a magma chamber all moving simultaneously. And of course, Yellowstone is a great example where multiple areas of loci of deformation are happening simultaneously. So this has really been the great boon of INSAR information. Question is it useful for deformation observations useful for understanding whether an eruption is about to happen? And I'll point you to a talk that Juliette Biggs will be giving tomorrow, summarizing in her paper. The short answer is yes. There are, of course, volcanoes that we know that deform and do not erupt, and that do erupt and don't deform, but in broad sense, most of the volcanoes fall into this category of showing deformation and also erupting, and also importantly, the ones that are not deforming are often the ones that are not erupting. So, but the key question is getting beyond this basic correlation between deformation and eruption to say, is an individual episode of deformation, can we say something about its characteristics in terms of magnitude, duration, the location where the volcano is happening? And this is an active area of research where new data sets like NISAR will be very critical for helping to understand that causal link. So let me just give you one example of this sort of concern. There was an extraordinary episode of uplift that occurred recently at Yellowstone. You can see the word extraordinary appears in the title. And the question is, was there an eruptive threat from this? And so one way of looking at this is to compile a list of similar deformation events around the world and whether they resulted in eruption or not. So I'm plotting you here. Let's see, does this laser point? Oh, nope, we're going backwards. All right. So on the x-axis is the duration of a given episode of deformation. On the y-axis is the magnitude of that pulse of deformation. And you can see in this case at Yellowstone, there are a lot of examples of deformation of pulses that occurred of similar magnitude and duration that didn't result in eruption. The other point I want to make from this sort of a plot is also the point that there are lots of pulses of deformation that occur on timescales less than a few days or weeks, and so this is why even 12 days will be a great improvement over what we have right now, but we need to use the constellation of global satellites to be able to really get down to a finer resolution than that. All right, so here's another pulse of a volcano that was discovered to be active by INSAR. So this is a great success of the INSAR method to find a volcano that's deforming in southern Chile at a rate currently of 25 centimeters per year. It's a phenomenal pulse of deformation that's occurred, and plotting that sort of pulse on the same sort of plot indicates that there's a lot smaller sample size in that vicinity as to whether this sort of pulse will result in eruption or not. And so to be able to better understand that sort of hazard from this sort of a pulse of deformation, which is pretty extreme, we have to ask the question of how many similar sorts of events have occurred worldwide. And so that led us to develop what we've called the Volcano Deformation Task Force, which is really looking at, retrospectively, looking at this quintupling in the number of volcanoes that are known to be deforming. How do we synthesize that into plots like the simple ones I just showed you in terms of the characteristics of the deformation, the magma composition that came out of the erupted volcano, and so forth. So that's one goal of our project, is to basically compile those sorts of observations. And one way that will be done, as I'll talk about, is to insert those sorts of observations directly into the Smithsonian database of eruption information. Going forward, we're going to, and even looking at the historical observations, a lot of volcano observatories who are responsible for monitoring these volcanoes would like to be able to have interferograms and time series to help with their hazard assessments, both looking forward and retrospectively to understand what's happened in the past. And so we need to come up with a way of doing that. And that is sort of the fourth goal, is making sure that we're linking these observations that are being made to the people who use them. And so the Volcano Deformation Task Force is a volunteer group. We are welcome to take new members all the time, but we just ask that you actually do something instead of just putting your name on our webpage to help us compile this list of volcano deformation events around the world. So please do contact us. You can find us on the Global Volcano Model webpage. So one task in terms of synthesizing the past results is to answer what volcanoes do we know, looking at the last 20 years of INSAR data, to be deforming, and what are their characteristics. So in red here I show you the approximately 214 volcanoes that have known published observations of ground deformation, and I've circled in blue a bunch of areas where there have been a lack of observations for a variety of reasons. One is that either the data was never collected or the data was not looked at. And so one goal of our task force is to help fill in the voids in this literature and understand what volcanoes might be deforming in those areas. And so one student looked at this sort of project and has looked at about 130 of these volcanoes and found that only about 100 of them actually had useful data. There are some volcanoes where basically no radar data is currently being acquired. These are usually very remote volcanoes, but that just means that the current set of satellites going back over the last 20 years are not collecting data over all the world's approximately 1,400 volcanoes that have been active in the Holocene time. So here's just a couple of examples. Iwo Jima is a known deforming but a couple of other ones at Pagan volcano with some recent eruptions, and Ambrum volcano in the Vanuatu has also has some deformation. Another poster you can check out on Thursday is in the Comoros Island. Another lava lake volcano has undergone a dike intrusion and some other interesting deformation that is still trying to be explained that might be due to seismic ground shaking. So still a lot to be done even with existing data, and that data is definitely incomplete in terms of monitoring all the volcanic deformation events. So how are we going to make these volcano deformation events available for people to understand, to look for trends and understand if a pulse of new deformation is a threat or not? Well, as a postdoc working at the Smithsonian named Jennifer Jay, who is working with the staff at the Smithsonian to incorporate deformation observations into the Smithsonian database of Holocene volcano eruptions. So they maintain a weekly report of volcanic deformation or volcanic activity, primarily eruptive, but we're working with them to incorporate sorts of events, and they might look something like this, that there will be a tab when you look at any individual volcano in the catalog that will include different types of deformation events, some information about the magnitude of the deformation, the location, the spatial extent, and perhaps some simple images from the literature that might include in that. And so Jennifer is working on making that available on the website within the next year or so. The next question is looking forward in terms of developing a volcanic monitoring system that we can link to the volcano observatories. And so this is just a link of the two of the primary satellites, Sentinel and ALOS-2, in terms of volcanoes they're observing, and they have a pretty good observation strategy for getting most of the world's volcanoes almost every cycle. There are some volcanoes here in red that are missed, again primarily remote or not very active volcanoes, but by combining these data sets together with the other missions that are currently flying, that we can get coverage over most of the volcanoes in the world on a fairly regular basis. And so what would that system look like? It's going to be a constellation of constellations, and how would we make that happen? And so it's starting to happen. There are some pilot projects that I'll highlight right now. And so primarily run by the Committee on Earth Observing Satellites and the Group on Earth Observations are starting to coordinate space agencies collecting imagery over particular areas, either called geohazard supersites and natural laboratories, or as part of pilot projects that I'll describe in a second. A bunch of different groups, I don't mean this group list to be comprehensive, are starting to use this data in a routine method or planning to do so to generate interferograms and time series that will then be used by end users, primarily in this case volcano observatories who are responsible for monitoring those data. And so an important consideration I think going forward is coordinating these efforts so that we're not giving volcano observatories 4, 5, 6, 7, 10 different solutions to what's happening at their volcano at the moment. And that information can also be saved in both historic databases, as we talked about from the Smithsonian, and the World Organization of Volcano Observatories also has a database where they would like to acquire and maintain archives of data of signs at times of unrest. And of course, there's also institutions that are involved in capacity building to help people to interpret this information. So let me just give you, this slide was meant to be complicated to show that there are a lot of people that are involved, and so making all the actors work together has sort of been, as a proof of concept, is being led by CEOS, focusing for the moment on a 3-year pilot project in Latin America to monitor all the volcanoes, approximately 315 Holocene active volcanoes. And we've come up with an observing strategy working with the space agencies to focus on quarterly observations at all the volcanoes, focusing monthly observations on perhaps about 50 volcanoes that are known to be potentially active, and of that fraction, about 15 are currently known to be deforming. And a variety of space agencies are coordinating that, as well as providing data and linking up with volcano observatories, and there will also be a poster on this on Thursday if you'd like to learn more about what we found so far. So let me just summarize where we are. Again, this is an exciting time for studying volcanic deformation. We're on the cusp of being able to do this on a global basis to look at volcanic deformation. We've had a rapid increase in the amount of volcanoes that we can study. But to maximize these utility of these observations, a global perspective is necessary. We can't just go on, if we have a random volcano in a part of the world that hasn't been active in the past, if it starts to deform, to be able to understand whether that poses a threat or not, we might need a global perspective as well as a detailed history of that individual volcano, as well as additional ground observation. So INSAR will be a critical tool for helping us to focus those resources. And again, this is going to require a community effort to make a global tool. This is not just one institution. This is not just one satellite. But to really answer this question, we will need a bunch of people to work together to both compile the database of past events and looking forward to make a system that is going to be most effective in terms of reducing volcanic hazard by working with observatories and using all of the resources that are available. And again, we want a system that is going to be lasting for decades going forward in the future when NISAR becomes a part of it, and that's what we are hoping to work together to do. So with that, I'll take any questions you guys have. Thanks for your attention.
Okay, any questions?
You're speaking of volcanoes as natural entities, which they are, of course, but they also have victims and people who need to respond. To what extent are you involving the people who would have to make decisions about citizen safety and so forth in your organization?
So in terms of the CEOS pilot project, all of the countries in Latin America are involved in receiving updates on the deformation that's occurring. One particular example Juliet Biggs can talk about is there's a volcanic crisis currently ongoing in Ecuador, and so she's been working closely with there, and some of her postdocs have actually been in Ecuador for both training and helping them to respond to the crisis through the data acquisition. So we are working as closely as we can with those, and Ecuador has been a great success in having that work.
Just to clarify, are there 5 times more deformations or 5 times more that you've observed?
More that we've observed.
Okay, thanks.
You're not causing them. One more question over there.
You are only considering uplift, and how do you deal with flank motion?
Everything counts as deformation. So if it's deforming, it's in the catalog.
Okay, since the icebreaker is starting now, I don't want to keep you from it. Thank you very much, Matt.